Hi everyone, so my name is Ayumi Surjadi. I am from A Level 1 and today I'm going to be discussing about mechanisms of breathing. So let's get started. So first we have inhalation, or known as breathing in. As you can see in the image, our diaphragm will move down and it will force the air into the airways. The intercostal muscles will then contract and enlarge the cavity even more, and the membranes will move with contraction. There is a surface tension in the alveoli and the surfactants, which will keep them from collapsing. The other muscles can force a deeper inhalation. Now we have exhalation, or known as breathing out. Since in inhalation we have the diaphragm moving downwards, in exhalation the diaphragm will move up and it will relax and the chest will contract. The diaphragm will move up, which will force the air out, and the intercostal muscle will relax and shrink the cavity. The membrane will still move with the contraction, and then the surface tension in the alveoli will keep them from collapsing, and the other muscles can force a deeper exhalation. Next, we have breathing. So breathing is an act of bringing air in and out of the lungs, consists of inhalation and exhalation. It's also known as an external mechanical process. Then we have cellular respiration. It's when glucose and oxygen combine to make carbon dioxide, water, and ATP. It's an internal chemical process. Then we have breathing and homeostasis. So if oxygen saturation falls, breathing will be accelerated to increase the volume of oxygen inspired. If carbon dioxide level increases, a substance like carbonic acid, it will be released to the blood, which will make hydrogen ions. So increase of hydrogen ions in the blood, it will also stimulate the increase of breathing rates. So breathing faster will increase the rate of oxygen that is brought in and the rate of which cellular respiration occurs at. Carbon dioxide levels primarily controls the rate of breathing, not oxygen. Next we have inspiration and expiration. So inhaling oxygen is the process of inspiration. Diaphragm contracts and travels downward when we breathe in, and this expands the space in our chest cavity when our lungs can expand. The chest cavity is therefore enlarged by the intercostal muscles between the ribs. Expiration is the process of organism releasing carbon dioxide. Diaphragm relaxes during expiration, reducing the volume of the cavity while increasing the pressure inside. As a result, the lungs constrict and the air escapes. Then we have gas exchange, which refers to the process of oxygen and carbon dioxide moving between the lungs and blood. So the movement of oxygens, there is the blood in capillaries surrounding the alveoli, which has lower concentration of oxygen than air in the alveoli, which has just been inhaled. Then we have the movement of carbon dioxide. The blood in the surrounding capillaries has a higher concentration of carbon dioxide than the inspired air due to being a waste product of cellular respiration. Then we have gas transport. As we know, glucose plus oxygen will make carbon dioxide, ATP, and water. The transfer of gas through conducting air via convection or bulk flow, followed by molecular diffusion into the alveoli and pulmonary capillaries, is known as ventilation or gas transport. This allows the gas exchange of oxygen, which will be uptake, and carbon dioxide will be eliminated. So we have key points. It's inhaling oxygen and expelling carbon dioxide is a physical process of breathing. Inhalation and exhalation are two basic processes involved in breathing. And then when a diaphragm and an external intercostal muscle contract, inspiration occurs. The diaphragm and intercostal muscle must relax during exhalation. The overall volume of air inside the lungs changes as much as around the lungs contract or relax, as does the pressure. The air rushes out when the pressure inside the lungs exceeds the pressure outside. The air rushes in if the opposite occurs. The lungs have increased compliance due to the high flexibility of lung tissue and low surface tension of fluid in lungs. So that's it for now. Thank you for listening to my presentation. Bye.